I wrote the rules of beekeeping from the honeybee's perspective.
Buzz.
Here I plugged into Google when they kept track of results and just asked about beekeeping, got 32 million results. After the first 1.5 million reading those results, I realized you're going to just go crazy on there. So I would suggest staying off the internet because you're going to get tons of just erroneous information there. People who have something to sell or trying to convince you of something. So instead of looking at it from the human perspective, I wrote the rules of beekeeping from the honeybee's perspective. First rule, they need a warm, dry cavity. When they moved into temperate areas, in tropical areas, they can live outside, hanging from a branch. In temperate areas with a cold winter, they need to have a dry and warm cavity, similar to human beings. So typically, it's a nest they find in a hollow of a tree or a rock cavity, or nowadays in abandoned buildings, that kind of thing. From an animal husbandry point of view, that's very easy. Any kind of dry box without much wind will do it. They don't care whether it's a Wari or a Topar hive or a Langstroth hive or styrofoam hive, as long as it keeps them warm enough and dry enough. So that's pretty simple from the husbandry standpoint. The second, they need food. Their food consists of nectar and pollen. Nectar being the carbohydrate source, pollen being the source of protein, minerals, lipids, sterols, and vitamins. So you have from a husbandry standpoint, you have a few choices. Number one, keep your bees somewhere where there's flowers blooming all the time. That's really easy. You live in Hawaii or somewhere. Number two, you can be a migratory beekeeper and move your bees to places where it's blooming. So many California beekeepers, when it dries up, they move their bees to other places. I did it for 25 years, to where there is stuff blooming. Number three choice is to give them supplemental feeding, artificial feeding. So give them sugar syrup, which they respond to just fine. And some of the better pollen subs, they grow on just fine. So that covers rule number two. Number three is every species on Earth has parasites. Half the species of life on Earth are parasitic. Okay, you guys all have parasitic mites on your faces right now, living in your hair follicles. Okay, and looking around, your immune systems all have them under control. Okay, otherwise your face would be all broken out in a scabies rash right there. So honeybees do pretty well with all their parasites. With the viruses, with bacteria, the fungi, generally they get along with it. They may have a little bit of epidemics of them when the weather turns cool or something. But when we introduced new parasites to them, like the tracheal mite, wiped out 70% of the hives in California when it invaded. 70% of them died. The varroa mite, chalk brood, when the Australians, during CCD, when we allowed import of Australian honeybees, I had just been to Australia the year before and said, oh, you got chalk brood too? And they go, oh yeah, it's no big deal. I said, but your chalk brood looks a little bit different than ours does in California. And what it is it's very strain specific. When people brought package bees in from Australia and brought them to California, if you didn't immediately requeen them with a California queen, that colony would die from chalk brood. Chalk brood just ate the Australian bees alive. So they did not have innate immunity specific for the California variant of chalk brood. But that opened my eyes, realizing how critical it was to have specific immunities to specific variants. Anyway, each time we bring in one of these new parasites, whether it's a fungus, whether it's a Nosema, a gut parasite, we have an invasive wave and we lose perhaps most of our colonies. And then the survivors get by and it's all over. Tracheal mite took about 5 years and all the non-resistant ones were eliminated. Chalk brood, what you see is like a wave for a year or two, everybody will have chalk brood or everybody will have European foul brood, and then it just goes away. And you can say, oh, it's because I did this or because I did that. No, it's because the bees develop an immune response to it, which they pass on to their offspring. The toughest one we got is the varroa mite, and that's what I'll be talking about later on this afternoon, and how to successfully manage that. So from a husbandry standpoint, if you're keeping an animal with an introduced novel parasite that it does not have innate immunity, it's your ethical responsibility for animal husbandry to control that parasite. I have no tolerance for treatment-free beekeeping if your bees are dying. Now, I'm one of the largest treatment-free beekeepers. We have one of the largest proportions of hives that require no treatment at all because I'm keeping a resistant stock. But the ones that are not resistant, I treat them. That's your ethical responsibility. So I'm all for treatment-free beekeeping, but not for neglectful beekeeping, which allows your livestock to die. Get the difference? Okay. And the rules. Okay.
How hard is it?
One more time. Warm dry cavity, food, control parasites. Anything else that anybody tells you on what you need to do as a beekeeper is a reflection on them, not upon the honeybees. Honeybees don't need very much from us. Just stay out of their way generally. So I suggest that you practice basic animal husbandry. It's the same for all livestock. All the same principles apply. There's no magic with honeybees. They're a managed livestock. Okay. Second is copy consistently successful local beekeepers. How do you tell if a beekeeper here in Alaska is consistently successful? They never buy bees. If they're buying bees, they are not a consistently successful beekeeper. If they are selling bees every year that they've produced, they are consistently successful. I would spend my time listening to the successful ones. When I travel around, I look for the beekeepers who are driving new pickup trucks. Okay, that tells me all I need to know. Oh, what do you do for keeping your bees alive and healthy and to make money? Okay, it's not the loudest person. It's not the person who gets interviewed by the press or whatever. It's the beekeeper who never has to buy bees because his number one problem is too many bees every spring to keep them from swarming, and he has to get rid of bees. So here's from 1920, the bee master of Warlow. I love this right here. He says, the bees have their definite plan for life, perfected through countless ages, and nothing you can do will ever turn them from it. Okay, get rid of your hubris. You might do anything. You can delay their work, or you can even thwart it altogether, but no one has ever succeeded in changing a single principle in bee life. And so the best bee master is always the one who most exactly obeys the orders from the hive. The best beekeeper is a servant to their bees, and that's what we do. We take care of our bees. And if you learn how to look at the combs, the bees are going to tell you what they need. So first thing is understand the ecological niche of the honeybee. Ecological niche is a business model. Every species on Earth has a business model to survive, or they've gone out of business, which we call extinction. So there's two objectives for the honeybee business model. First one, store enough food in the form of honey to survive dearths. The dearth for you guys being your winter period. The dearth for us is from July until next February. That's our dearth, very long dearth also, but not a dearth due to cold necessarily. Same down in Mexico. The winter in Mexico starts in July and ends in November. And spring starts in November when they get rain and it starts going. So it has nothing to do with photo period or day and length or calendar month. It has to do when there's food coming into the hive. Okay, now from a husbandry standpoint, the bee's objective and the beekeeper's objective overlap. We want our bees to store as much honey as possible. So we do everything we can, and we do things that are unnatural. For example, putting a box of empty comb above the cluster. That will never happen in nature because the honey is always at the top in nature. It's unnatural, but it allows the bees to store honey more easily, so we both benefit from it. So even though we're doing something unnatural, it benefits the bees and it benefits us. Okay, so we work with our bees on that. Their second objective is the honeybees don't realize that you exist as a beekeeper. They don't realize that they're living in a man-made beehive. As far as the bees are concerned, they're living in a hollow tree. They have no idea that beekeeping is involved. The moment they feel they've filled that cavity with enough food and there's no more room to fill, there's only one thing left to do, and that's to reproduce. So they just start swarming and swarming and swarming. They'll swarm all year long and try to send their successful bloodlines out there to the environment. Well, that's contrary to the beekeeper's objective. So we look at that a little bit later, but that trying to find that balance, and I guess Tim's going to talk about that, between getting your colonies to grow and keeping them from swarm is always one of the beekeepers' things. I've got a whole PowerPoint just on swarm management. So as I said, colony development goes through, this is 3 different seasons right here. So this is your colony population on this axis right here. You guys see my pointer? Is my pointer on there? Wow. How can that be? Okay, display settings. Let's try to duplicate. Nope. You see it?
There it is.
Oh, okay, got it. Okay, so this is your colony population on this axis right here. Here's your colony population, the black line. Here is food availability for my region, starting in springtime, peaking usually in the middle of May through June, dropping off, and maybe a little bit of food coming in late in the season. And there's 4 different modes in the honeybee's life cycle. The first is when pollen initiates, they go into the buildup mode. They get going. They start a little bit early so they get the jump on the other pollinators because they compete against all the pollinators. The advantage of the honeybees is they have a huge workforce that overwinters and they can get out there rather than a single mated queen the other pollinators have. So they go into the buildup mode. Once they reach equilibrium with brood production, peak on brood production, then they go right into reproduction mode. And that's where you see swarming then. And that depends upon what region you live in. And then they try to coincide swarming to be prior to the main honey flow. That doesn't happen in all regions, but that's the ideal for the honeybees. That way the swarms have a chance to survive because they're going to swarm into a honey flow and be able to put away enough stores to make it through the following dearth period. Once the main honey flow is over, they go into a dearth period. Again, independent of day length, independent of anything. Temperature-wise, it's only as long as it's flight temperature, it doesn't have to be a dearth period. So that's dearth. And then they repeat this over and over again. Whoops. Wrong button. So in the hollow tree cavity, the honeybee colony moves like a yo-yo. So as it stores honey above, it fills these cells with nectar, and then they build new comb down below, and the queen lays down here. And when these bees emerge here, those cells get filled full of nectar ripened into honey. So they push the brood nest downward. Then during dearth period, they eat their way up slowly, and if they hit the top, they starve to death. Okay, that's what you guys are going to try to avoid during winter, is having them hit the top and starving to death. Okay, now everybody loves the queen. God, you got a good picture of a queen bee up there. That's beekeeper pornography. Beekeepers just love looking at pictures of big fat queen bees, okay? The queen is the only normal female in the colony. She's a normal egg-laying Hymenoptera female. The special bees are the worker bees, those who give up reproductive ability in order to raise their sisters, okay? So don't get it backwards. There's nothing special about a queen bee at all. The special ones are these unusual sterile worker bees. So the queen does have a function for her pheromone output. Is kind of the heart or soul of the colony, but she makes no rules, okay? The ones who make all the rules are the nurse bees. The nurse bees control the food supply of the hive, the protein supply of the food. They decide when the queen lays an egg whether they're going to cannibalize it or feed it. That's their choice. And during the summer, they may cannibalize every egg that the queen lays in our area. And they also share food with every other bee in the hive, protein. So they're the only ones that are able to actually digest pollen. A forager bee cannot digest pollen, so they do not eat pollen. If you're doing gut squashes right here for Nosema, and you squash nurse bees, the water will turn orange or yellow due to the pollen in their stomachs. If you collect forager bees from the entrance, there will be no color change because they don't have any pollen in their stomachs. If they need protein, they need to beg it from the nurse bees. And this process is called prophylaxis, the sharing of food. And they share it throughout the colony. Every bee in the hive knows the nutritional state of that hive at any time by how willing the nurse bees are to share that jelly with them. So jelly it's a uniform food made up 3 components, and it's adjusted for who they're feeding, whether it's a drone larva are a queen larva or whatever age of queen larva and whatever age of worker larva. So it's not just one jelly, it's different forms, but it's always the same three components in different proportions. So we get to this attrition and recruitment. So recruitment is them rearing new workers. This is the way that honeybees deal with any kind of problem. They just try to just recruit a whole bunch of new workers and say, oh, bygones be bygones, let's keep building up. And attrition is that loss of workers due to their aging, which is a good thing. And when I modeled it out, if those worker bees lived longer than they do, the colonies would all starve during the winter. They have to have their workers wear out and die to get that so they can decrease the population size when they go into dearth mode so that they don't eat up all their stores and die. So honeybees are intentionally, evolutionarily, short-lived for that reason. And here's the change in colony population calculated day by day. So here it's a colony going from about 8,000 bees from an overwintered small cluster up to 55,000 bees, which is a fairly normal cluster size. This is your daily net change in adult bee population. So when they are building up in the springtime, they're increasing by a rate of about 500 additional bees per day. It takes about 2,000 bees to fully cover a comb. So every 4 days, you've got an additional comb covered with bees. And finally, when recruitment comes into equilibrium with attrition, they top out and get your maximum population at about 40 times the recruitment rate. Now, for those of you who are loath to sacrifice 300 bees for a mite wash to protect your colony from varroa, realize if they're increasing at 500 bees a day and the queen is laying 1,500 eggs a day, how many bees are dying of natural mortality every single day? That's an arithmetical question for anybody. If the queen's laying 1,500 eggs a day and they're increasing by 500 eggs a day, 1,000 bees are dying every single day of natural attrition. Sacrificing 300 bees once or twice a year to save your colony from varroa is no big deal. Any bee would readily sacrifice its life to protect its colony. So Lloyd Harris in Manitoba in the 1970s did a great master's thesis, collected data on the survivorship of bees by color marking 100 bees at a time in a number of hives and keeping track of them over 2 years. Huge amount of data. And I asked him if I could colorize his data, and he gave me permission. And we've worked together a lot. And I came up with this chart. It's on my website. Very informative, showing the age of the population structure, with the top of the line being your total population of the bees in the hive in Manitoba, Canada, over the dates, and every 12 days, the age class, because you have sealed brood for 12 days. If you go in every 12 days, you know what that age class of bees is every 12 days. That would be your recruitment rate. The dotted line is the amount of brood of all ages, eggs, larvae, and pupae, and the colors are the adult bees. Notice in the spring turnover, you have over twice as many immature bees as you have adult bees, okay? Very different situation. And your average age of the bee in the hive, you're getting up to 117 days, average age, which very drops to a teenage cohort and early 20s going through the rest of the season until they start going back into dearth period again. So it's the bees age-wise, chronological age is very different during the winter than it is during the summer. And I broke this down in a series of articles on my website. You can read it at your leisure. I call it Understanding Colony Buildup and Decline. We're going to do a very short version of that now. And I suggest that every local beekeeper group make a phenological table like this for the benefit of their new members. That phenological means based upon plant blooming time rather than date. Where I live, I can drive a half an hour and be a whole month later in the season because of elevation change. I'm sure it would be similar around here. And then over that, you lay your suggested management practice on that. This is very helpful to beginning beekeepers in any club. This is on my first year beekeeping website for my area. Copy it for your own club for the benefit of the beginners. And then I would, for your management decisions, stay off the internet, and you can base your management decisions on what the biological needs of the colony are. Before Varroa, I would tell people, if you don't know exactly what you're doing, don't do anything. Leave the bees alone. They'll take care of themselves. They're better off without you than with you. Since Varroa, you generally do have to control for Varroa. But other than controlling for Varroa, you don't generally need to do much management for your honeybees colonies other than just giving them the appropriate amount of space at the right time. So learn how to read the combs. Look at the combs and analyze what the bees actually need. You want to assess the main factors are the honey. If the honey looks dark like this, that means it's been stored for a while and the airspace has dissipated out through the capping and the wax has touched the honey and then it looks dark. So that's older honey. If it's white still, then that's fresh honey right there. Then you have fresh pollen coming in right here. And then bee bread, which is pollen that they've added nectar to, packed the air out of it and allowed it to ferment and acidify, kind of like making sauerkraut. The nurse bees are the bees then that feed on the fresh pollen and bee bread. And then this is called open brood right here. And this is called sealed brood or capped over brood. This also is called Varroa food right here. This is where Varroa reproduces. So you guys are not only beekeepers, you're also Varroa keepers. Some of you are far more successful at being Varroa keepers than you are at being beekeepers. So you want to flip that around, okay? So the question is, the nurse bees don't fly. They may go out to poop a little bit, but they don't monitor the environment outside. So how do they know what's happening outside the hive? So let me give you a view of what they see inside the hive. Bees live most of their life in total darkness and then fly out in the sun for 2 weeks and die. Okay? So forget your human bias towards vision. That is not what bees use most of their life. They live in a world of smell and a little bit of touch for most of their life. So what the nurses pay attention to is the incoming nectar, which means that there's not only an energy source to make the jelly and to keep the cluster warm. You need the energy to keep it warm during cool weather in the spring, but also enough water to make the jelly. Jelly is 70% water, so they need that moisture coming in to make the jelly also. And then the incoming pollen, and whether you have a reserve of that, and then the young larval pheromone down here, which tells every bee in the colony whether or not the colony is in buildup mode. There's also effects from the queen pheromone, the emerging workers pushing the bees off, and feedback from the foragers. But these are the main cues right here are these 3 cues right here. Now, when you look at a comb, everybody goes, oh yeah, you always have this arc of bee bread around. That is not where the foragers preferentially store it. That's the last place they store it. They immediately come in and try to store it right in the middle, smack dab in the middle of the brood area. As soon as a worker emerges, the foragers want to fill that cell full of bee bread right there. Okay, you don't see it much because it's immediately consumed by the nurse bees. It turns over within that first day very, very quickly. Only if there's no room left here for them to store it will the forager go, oh, I guess I'll go to the edge and I'll store it right here. And then that gets fermented into stores. As far as the nurses are concerned, this is like that pantry you have off the side of the kitchen with all the canned food and all that jam you made 10 years ago you're going to eat someday. Okay, it's survival food, but it is not stimulatory to them in any way. So that's why having combs of pollen outside the brood nest does not stimulate brood buildup. Where they want to see it is right here next to the larvae, which they'll consume, convert to jelly, and then share with the rest of the bees in the hive, to the queen, and to the other workers. So what you want to pay attention to is this interface right between the honey. Now here's some freshly stored honey here. A very slim band of bee bread here and the brood. Now this bee bread may be all gone by morning. They don't need, there's a misconception that they have to ferment pollen to make it nutritious. That's nonsense. You go out in the springtime, you're going to have a colony growing at maximum growth and not see one bit of bee bread because they're consuming it all every single day overnight. The nurses prefer fresh pollen to bee bread. Okay, just like you probably prefer, fresh cabbage in a salad to old sauerkraut, kind of the same type of thing. So you have your energy reserves, which is the capped honey. Then you have a emergency protein reserve, which is the bee bread. Then you have all the brood right here, which is your energy and protein demand. Energy demand, if they have to keep it warm, and protein demand just to grow. You have two interfaces. You have the energy interface is this one line of cells right here between the honey and any stored bee bread. So this one line of open cells would contain one of two things. Uncapped honey, so you can stick a twig in there and see if it's honey or not, or it's going to be nectar being ripened. So in the colony buildup mode, that'll be nectar pushing the brood nest down. When they're in survival mode, then that's going to be uncapped honey as they eat their way up. And then here's your protein interface right between the brood and the honey. So if they are really hungry, the nurses will eat their way into here. If there's a surplus coming in, this band will get wider and wider. But the two interfaces are at this edge and at that edge. That's what you can pay attention to in the hive. So let's go through a year now. In general, in most areas, the first pollens are the tree pollens. And some of them are completely nutritious for the bees. And that triggers spring buildup. So Lloyd's data right here in Manitoba, 1st of March, some of the tree pollens start coming in, and you see that you get brood rearing initiated right here in earnest. Colonies will rear a little bit of brood during the winter. Your colonies here will be rearing brood sporadically throughout the winter. And that's why we had the misconception that Trophoelaps mite was not going to be a problem because of winter. Don't buy that. Trophoelaps mite will, when it arrives, will decimate most beekeepers, okay? And it can survive through the winter because the bees do sporadically rear some brood. So here's a condition. My colony, this is fresh alder pollen from the alder trees coming in, comes in abundance if it's not raining every day, and they rear beautiful patches of brood on this tree pollen. That stimulates the nurses to produce a whole bunch of jelly, and instead of cannibalizing the eggs, to feed the larvae abundantly. And then this young brood pheromone from the first and second instar larvae then tells everybody in the hive, we are in buildup mode. Shift from what you're doing to go buildup mode. That means start foraging for more pollen because we got hungry larvae, bring in nectar also, and activates the whole hive. Tells them the queen is working. Then you have the spring turnover. Now, once these bees initiate foraging, these have been long-lived bees. They've never flown. Okay, these winter bees, okay? All that is just nurses in arrested development. They're waiting for the next step. The next step in nurse development is when the round of brood that they reared emerges, and then those young bees push the nurses out of the brood nest and take over their job. Nurses then become mid-age bees and then transition to foraging. Once they transition to foraging, they got maybe 2 weeks to live. And that's what happens here. So you initiate brood rearing right here, and a month and a half, 2 months later, all this whole cohort of bee that has lived for almost 200 days is all gone. That's called the spring turnover. And they need to replace themselves with this new cohorts of bees. These are bees less than 12 days old. These are bees 18 to 24 days, or 13, 24, 25 to 36 days old right here. So you see the population age structure changes tremendously from old bees with a very, very few young bees to almost all relatively young bees. When we move bees to almonds, if you take your bees directly out of winter storage and put them on almonds, and they all start flying because of all the almond bloom, they don't have any brood to emerge and replace them, and the colony collapses. So you got to take your bees out of winter storage in advance, get them to get sealed brood in the colony, and then when you move them to almonds, then they can forage, and you have replacement bees emerging. So here's a picture again, this is late January in my area, very early in the buildup phase. And these are all older bees that have survived the winter that are desperately rearing their replacements, this beautiful brood right here. And then you get parasite problems. So this is a 2-year graph here showing how Nosema and chalk brood are typically, and European foul brood are springtime issues when it's cooler and you have more brood than you have nurse bees, okay? So they are nutritionally stressed. So you get Nosema, European foul brood, and chalk brood. Nosema, especially whenever you have a pollen flow, that's when you see Nosema explode. That would be your case too. If you have a strong pollen flow, you're going to get high Nosema counts.
I'm sorry, last minute.
Okay, so during that spring turnover, you have maybe twice, sometimes 3 times as many immature bees as adult bees. That means there's not enough nurses to feed them all well, all the brood, which means that the parasites that require nutritional stress, like chalk brood and European flower brood, can explode. Okay, that's what happens in blackberries. Okay, you get nutritional stress in there because they don't get any blackberry pollen. Nosema explodes anytime the bees are bringing in a lot of pollen or if you're feeding pollen sub. So if you took your bee samples for analysis from the entrance, it's going to scare the shit out of you. Okay, if you took them from the nurse bees, you wouldn't see anywhere near as high a count of Nosema. Okay. Then you don't usually have a problem. Maybe American flower brood. We haven't seen American flower brood for 20 years in our county. I don't know. Do you guys see it up here anymore? Good.
20 years ago.
Yeah. So that's one of the great mysteries. What the hell happened to American flower brood? That used to be our only disease. And then late summer, varroa and deforming virus become a problem. You may see Nosema with this fall pollen flow and the paralytic viruses over the winter, and then it repeats. So know your seasonality of diseases, when to look. Nosema this is a picture I took, 400x. Here's a bee's tracheal tube. You can see the striations of the gut musculature here. Every one of these little white ovals is a Nosema spore. That's how full their gut tissue is for Nosema. Just unbelievable. You have 1 billion spores of Nosema in a single bee. So if you take a sample of 10 bees and give it to Dave Wick, and he crushes 10, 1 bee can give you a sky-high spore count, even though it's only 1 bee out of 10 that are infected with Nosema. So spore counts are not all that meaningful with Nosema. You have to do a bee by bee squash. And I took these pictures during CCD. So pull a 3-frame colony out. This was in February before almonds. Beautiful brood. But I would go, oh shit, what's the matter with this picture? This is cold weather, February, early on, beautiful brood. What's wrong with this picture? It's going to collapse. How do I know? Not enough adult bees to keep that warm on a cold night. That means your attrition rate is exceeding your recruitment rate. Just one glance right there. You get one cold night, and the next day it looks like this. Okay? So what they do is you can look at this band of bee bread here. That tells you how big the brood nest was maybe 2 days ago. During the night, to keep warm, the cluster contracted to a ball, chilled all the brood. The next day they chew that brood out, get it out of there. This is very typical during that CCD epidemic. Another misconception is that this indicates the colony has Nosema. Yeah?
For the new beekeepers, please explain what CDB or CDC is.
CCD was colony collapse disorder. It coincided with the invasion of Nosema ceranae. There were a number of things happening, but it was different than anything that we had seen to any extent before. So it was given that name. Everybody who had something to sell or an idea to pitch blamed it on their thing. So if you were anti-cell phones, it was because of cell phones. If you were anti-windmills, it was because of the windmills. If you were anti-neonicotinoid pesticides, it was because of the neonicotinoids. If you were against whatever it was, that they blamed it. It was mainly the invasion of Nosema ceranae, coupled with some variants of some pretty strong viruses that caused it. And by 2000, we started seeing it in 2003. It made the news in 2007, and by 2010, it was all gone. Okay, now what they call CCD is another term for PPB, which is piss poor beekeeping, or lack of varroa management. But because you get ELAP funds only for CCD, not for PPB, then it's reported as CCD rather than PPB, okay? You don't get paid for PPD. Okay, so again, take this stuff with a grain of salt. Common misconception that dysentery indicates the colony has Nosema. No, there is no evidence that Nosema has ever caused dysentery, and plenty of evidence that it does not cause dysentery, either Nosema apis or Nosema ceranae. But if it has dysentery and the bees start pooping inside the hive, it can spread Nosema. But Nosema does not cause dysentery. Dysentery is caused either a water imbalance in the bees because they're confined, or because of their eating of food that is irritating to the digestive tract or that they can't fully digest. but it's not Nosema. The only way to confirm Nosema is by microscopy. So here's a bee seta hair right here. These are pollen grains right here. These little glowing things are Nosema ceranae spores right there. That's at 400 times magnification. Only way you can diagnose Nosema. And Nosema is an enigma. Everybody talks about it, but the research from Canada shows no correlation between winter loss and Nosema counts in your colonies. So even though lots of people like to blame things on Nosema, it's not normally a problem for the bees. So now the colony goes into linear growth phase. Lots of pollen come in, they can grow quickly. This is data from Nolan back from 1932. Scientists have not gotten any smarter since then. Well, shoot, I was in Peru looking at the Incas where they grew all the seed for all their farmers. Those guys were, I get goosebumps, they were geniuses. Humans have not gotten any smarter at all in the last few thousand years. So some of this data research back in the 1800s and 1900s is incredibly good research data. And he studied thousands of package bees colonies and looked at their growth and showed it's just a linear growth phase. It's not like a sine or anything like that, or a S-shaped curve. It's a straight curve up until they reach the equilibrium where the death rate comes in equilibrium with the birth rate. And that's typically, it takes about 40 days to reach that, and then you get to equilibrium at about 40 times the recruitment rate from the queen's eggs right here. So you can show this, you see this right here, this roughly 40 days of this maximum growth in Lloyd's colonies. And these guys can be really hungry. They can blow through, because they have to heat the brood nest, especially if you get cold weather, they can blow through their stores right away. So in most areas, I know about Alaska, very few colonies ever starve during the winter. They starve after they begin brood rearing in the late winter. And that's when you go through the stores to heat the brood nest up, and then they start blasting through the honey reserves. Big danger of starvation. And a growing colony, if they're flying, the worker population turns over. Average age of a worker mortality or longevity is 35 days. So that means once a month, they turn over the population of the bees. That requires 1 pound to 2 pounds of pollen every single week just to keep them established. So here's a colony expanding up into the honey stores right here, living hand to mouth. And then it rains. Karl Kroelschein from Germany found that if you put sprinklers over the top of hives and turns them on, within less than an hour, the nurses cut back on the amount of jelly that they give to the larvae. Very rapid response to lack of cue from incoming foragers and pollen. So when I analyzed Lori's data, I saw this. Here's your immature bees. This is your brood. I saw this hiccup right here. And I go, what the heck happened there? So I looked back on weather history for that week in 1976 in Manitoba, Canada. And sure enough, a rain and windstorm blew in right then. Rain and snowstorm, and that the bees cannibalize the brood right then. So they will cannibalize at any time. Here's a picture of my sons. We got hit by a springtime during a very strong nectar and pollen flow. We had just supered all over our hives. And this came in. All the other beekeepers in town huddled around their TVs going, holy shit, what a miserable weather. They all lost their hives, every single one. We're the only ones in our whole county who kept our hives alive because we were being beekeepers. Beekeepers don't sit watching TV when your colonies are starving. Okay? We went out and fed them, kept them alive. 4 days after that storm, that's what the unfed colonies looked like. They had consumed all their honey, all their bee bread, and consumed all their young larvae and actually some of the pupae even. So desperate survival mode, just 4 days after that storm. We also see now with climate change, areas where we have put nukes out for, almost 40 years to the same yards and never had to feed them, and now we have to feed them. So this is like right after apple bloom, full on springtime, and colonies starving, not fully, but a bunch of the bees dying, and then we go, oh my God, what's this? And it gives them sugar syrup, and they respond, and then it starts blooming again. So we get breaks now in the nectar and pollen flows that we never used to get. So we're having to adapt to climate change quite a bit in California. And yes, starvation is a failure of husbandry. Sugar is really cheap and easy. A bag of granulated sugar will save a hive. I've saved hot colonies with a can of Coca-Cola. Okay, they just need sugar. Okay, so yes, if you see this, all these tails up, these starved out bees, that's your fault. Here I am treating my bees better than I treat my own children. When my sons grew up, California in the springtime during buildup, it often rains. Sometimes we wear foul weather gear for 30 days straight. Work bees every day, wearing foul weather gear every day. People say, Randy, you're out feeding your bees when it's raining and snowing? And I said, well, duh. When it's warm and sunny, they feed themselves. That's your job as a beekeeper. They not only need pollen, but they need nectar because they don't forage for water when it's raining. There's no nectar coming in. There's not enough moisture coming in for the nurses to make jelly. So they want a light syrup along with that pollen stuff if it's raining. So again, it seems counterintuitive. You think, oh, it's raining, it's really wet. There's no water foragers when it's wet. They don't fly. So the colony gets very thirsty when it's raining. Yeah.
What's your ratio on a light syrup?
You can 1-to-1 would be the heaviest. You can even go more water, 1 part sugar to 1 part water. You can even go maybe 1-to-2. It depends on see how they respond to it. Because you're trying to give them moisture as much as you're trying to give them sugar. So a lot of guys feed it 40% sugar syrup. Hive inspection. A typical hive inspection for me takes about 15 seconds. Okay, I pop the lid on a double deep. You pop the lid off the double deep, pull out a center comb and look at it. This one right here. Oh, adequate honey reserves. Oh, adequate bee bread reserves. Oh, obviously no larval mortality. Done. Boom. That's all you got to see. No other question to answer. Now, if any of those 3 things were lacking, then I would dig in deeper and figure out what it was. So it's very intrusive to a colony to pull every frame out. Now, if you're a beginning beekeeper, get out there, get nucleus colonies, and go into them every couple of days and learn your bees. Okay, the only way we're going to do that is by going in there every couple of days, seeing the queens laying eggs, seeing them, the larvae develop, seeing them emerge. Really get a feeling. It's much easier to get a feeling of bees working in little tiny nucleus colonies than it is on a great big strong colony. So we sell 1,000 nukes every spring. We have Saturdays, this pickup day, and everybody goes in a circle around our bee yard, and they come up in the front of the line of cars, and my sons say, are you beginning beekeeper or experienced? Oh, beginning. Well, they go to the left side, and they give you a weak nuke. If you're experienced, they go to the strong side, said, this nuke's going to starve tomorrow if you don't feed it, and it's got to be in a double, and it's in a single within 2 days, or it's going to swarm. Okay? You don't want to give one of those to a beginner. Okay? You want to give them a weak nuke. Okay? So just a tip for you guys, for beginners. This is healthy brood, very, very solid brood pattern, very few missing holes. This is spotty brood. Now, springtime, that would generally mean European foul brood. During dearth, that means they're cannibalizing the larvae, nothing to worry about. So it depends upon the time of year to look. You want to look at the larval age progression, where the queen starts in the center and lays in a ring eggs, and it takes about 3 days to lay out a full deep length-swath comb. So you want to see a step down in age from the biggest larvae to the eggs, very even step down. Look more close up, see the step down in larval ages going down to very young larvae. That means you have very high larval survival. Look at this one. Notice you got little tiny larvae right next to older larvae right here, all mixed up in here and some a little bit off covered. This is a sick colony. This is not good larval survival. That means you take a look in there and see what it is. Very often it means you either got chalk brood or European foul brood. This is chalk brood. There's no treatment for it. It's a fungal disease. It happens when the larvae get slightly chilled. That allows the oxygen content in the human lymph to increase, and then the fungus can grow. The bees respond by creating a fever, which reduces the oxygen content, and then the bees can cure themselves of the chalk brood. There's no cure for chalk brood. If it persists, try requeening, because you may have a strain of chalk brood that you're, just like with the Australian bees, that your bees are not yet immune to. Then this is European foul brood, where it's younger larvae. They turn yellowish and they twist like this in the cells. It's generally due to hunger. they're inadequately fed in the cells, and very generally easily treated with oxytetracycline or terramycin. If it doesn't go away, generally it'll go away on a good pollen flow. But I know a lot of guys growing the blueberries and stuff, they're seeing it not go away. And there's variants of this. So you're going to see a wave in your area of everybody's complaining about European foulbrood, and then they'll get immunity to that variant, and then it'll go away. Best nutrition is a palette of mixed pollens. So you have more chance. The bees cannot detect how nutritious the pollen is. So they just go for a diversity of pollen sources. By chance, you get a amino acid balance that's good by doing that. For example, if they got only dandelion pollen, a colony will starve to death. It's missing 2 essential amino acids, so they cannot grow in dandelion pollen alone. And dandelion pollen in conjunction with something else can be nutritious. We have from blackberry rust fungus down in our area, and in the fall, you see these big cones of all this bee bread. There's no pollen there at all. That's fungal spores from blackberry rust fungus, and look at the brood dying. Those are all dying, sick larvae right there.
So they're collecting the pollen, they're collecting.
Well, there is no pollen. So the rust fungus tricks pollinators by putting out a sugary secretion for them to transfer the spores from leaf to leaf to get cross-pollination of the fungus. That took us a while to figure that one out. Yeah, I couldn't identify what we call them fried eggs, because the spores look like fried eggs in the bee's gut. And it took me some real sleuthing to figure out that it was rust fungus spores. So the main thing to look at, your number one indicator, is the amount of jelly they put around the second instar larvae. Okay, so that's a second instar larvae. First instar larvae are just the size of the egg. Second day, they're second instar larvae. There's not much jelly put around the first day, but by second day, a well-fed colony will cover the bottom of the cell wall to wall with jelly. Okay, that tells you you're the best beekeeper in the world. There's nothing you can do wrong. That colony is doing great. Okay, it'd be hard to kill that colony, because if there's that much nutrition coming in. So this is abundant jelly around the larvae right here. Look here. These larvae are getting fed just enough to stay alive. So they will grow into a normal looking bee, but that bee will begin foraging at an earlier age in its life and be a shorter lived bee. So it will survive, but they don't reach their full potential. So these are hungry larvae right here. The easiest way to tell the nutritional status, you just look at the jelly. So we pull up to the yard, first guy out of the truck, runs over there, opens the hive, said, "Oh, it's looking wet." And we go, "Great, no pollen sub, don't think they're going to be fine." "Oh, Bruce, looks a little bit dry." "Okay, let's crack out the pollen sub." Okay. Here they are, larvae swimming in jelly. Scant jelly, just barely enough to keep them alive. Okay, that's one of the best things I can show you for learning how to read the combs. Now we get to swarming. Here's the amount of immatures. Notice it tops out right here. Queens reach their maximum egg laying capacity. That's when the colony swarms. Especially when you have fresh nectar coming in, and instead of these combs making room for the queen to lay, they backfill them with nectar. 4 days later, there's no young larval pheromone, no E-beta-ocimine from the young larvae. That tells every bee in the hive, "Oh my God, either something happened to the queen or we filled the cavity." Only one thing to do, make queen cells. So they're either going to swarm or they're going to make emergency or supersedure cells, because they only have 4 days or 3 more days, actually only 2 more days after that, because all the eggs will be gone by then. You only have 3 days of eggs, so they got to make the decision really fast whether to replace that queen. Also, if you see white wax, that means they're telling you we're out of room. This is a time where you add foundation to draw. There's no magic to getting foundation drawing other than waiting until the colony has white wax, either by nectar flow or heavy supplemental feeding. And then, so they reproduce when they sense that the colony has filled their cavity. Again, they think they're living in a hollow tree. So what you need to do to prevent swarming is to make them think that they're not in they haven't filled the cavity. And this is the challenge for all beekeepers. You want to build your colonies up to the maximum strength for honey flow, but then You don't want them to swarm. And I know Tim's going to be talking about this. He's got some tricks, which I agree with, to prevent that swarming. So the queen needs the easiest way is draw an empty drawn comb immediately above the brood nest with no honey band between them. You do that, the queen starts laying there, young larval pheromone comes out, and they will actually tear down the swarm cells by themselves. Okay, so this is a way to reverse the swarm impulse. Make sure the queen always has young brood. Jim will talk about other ways. Once you get to this point where you see queen cells hanging from the bottom bars, it's too late. No sense cutting out queen cells, okay? You're not going to find them all. You're going to mess something up. The queen may have already left, and then you're really screwed up the colony. So this is the time that you make splits. Now I got a whole PowerPoint just on colony division. And then this is colony reproduction. They're sending out a swarm. The problems with swarming, one, you're going to have a reduced honey crop, okay? Number two, your neighbors may complain about the swarms moving into their cracks and everything. Three is if you now have a competitor for resources out there, it's going to be hitting those same flowers. Most of the mites are left in the parent hive. 70% of the mites stay behind in the parent hive, even though half the bees left. So now you have a hive even more badly infested with varroa. And if that escaped swarm survives, up here it wouldn't survive over the winter, I guess. Anywhere else, it was on the second year, it becomes a varroa factory and spreads varroa back to everybody else. Now, when they swarm when they're full of sealed brood. If you look right here, one adult bee covers 3 cells. That means you have a 3-to-1 expansion when those combs emerge. So when one comb of sealed brood emerges into, let's do the math, how many combs cover the bees? 3, very good. Yeah, so you have this very quick rebound of that colony after swarming. So what we do is we kill 3 birds in 1 stone. We come back from almond pollination with our colonies just pushing 20 frames covered with bees right on the edge of swarming. So we split them right then. We rear new queens and we control varroa all the time. We prevent swarming, control varroa, and requeen the colonies. So, oops. And I will go into this more later on, the next presentation. Now, as far as varroa management, we're going to talk more, but you get your best bang for the buck by controlling varroa early in the season, okay, rather than try to bring it down later. Okay, let's go to the maiden honey flow. Ideally, you want to get your top population right at the beginning of the honey flow. You don't want to be building up during the flow because none of those bees are going to be old enough to be foragers. Stronger colonies make proportionally more honey per bee than a weaker colony. You're better off combining 2 medium-strength colonies than keeping them separate. So we make tons of splits in the springtime to prevent swarming, and beginning honey flow, we will combine them back together. We don't even look for the queens, just put them back together and have strong honey-producing colonies. That also solves the marriage problem when the spouse says, I thought this was going to be a hobby. You got 34 hives in the backyard. You say you're going to split them again? Just when the honey flow starts, just put them back together. And it makes super hives then. Okay, honey flow begins. You start shaking nectar out of the combs. That forces the brood nest downward, and the bees go into honey storage mode. They don't care about brood ring anymore. Once they've filled the empty cells, they start producing wax from the wax glands right here, so they can build more comb. And then white wax out of storage. Now it's the only time you can draw a foundation. Be ready to get on there. Yeah.
Did you say shaking nectar out of the comb?
Yeah, we call it shake. So we'll say, were they shaking today? Oh yeah, shaking a little bit over this yard, but shaking heavy. That means
What do you mean when you shake it?
you hold the comb horizontal and give it a shake. If it comes out like a watering can, they're shaking nectar.
Oh, I see. I
Got
thought you meant you were shaking all the nectar. You're just doing a test.
A test.
Okay.
Yeah. We'll ask ourselves, are they shaking? Okay. And there's feedback loops I'm not going to go into in the colony to balance the proportion of nurse bees to foragers, usually about a 1-to-1. Yeah.
Just real quick. Don't shake it over the grass. Turn it sideways, shake it over the hive. It drops onto all the top bar. You know how fresh the nectar is. And they just put it right back in the cones there. So
And in our environment in California, if you did it right now, they'd shake. You're going to do one more thing.
Rattle and roll.
You're going to taste it
Oh, you taste it.
to see whether it's nectar or water.
Oh, right.
Because they fill the combs full of water for evaporative cooling now. So just because you're shaking doesn't mean it's nectar. You got to taste it too. Okay, I don't know if that happens here. Okay, and in Lloyd's data, look at the brood right here. Full and boom. Because the bees deprioritize brood rearing. Any bees that they raise at this time will be more mouths to feed after the honey flow. So they allow the forage or the mid-age bees to fill the brood nest full of honey and stop the queen from laying entirely. That's normal and natural. Okay, what we do from husbandry is we trick the bees by suddenly enlarging their tree cavity so they don't get the signal that they have filled the cavity. Okay? This,
Don't look like that.
this is Tim Ives. I visited him in Indiana. Back when I was researching colony collapse and the neonicotinoid seed treatments, he is completely surrounded, other than this one piece you see right here, with seed-treated, genetically modified corn and soybeans as far as you can see. And he laughs at it. He goes, this is the best we ever had. Makes 400-pound crops of honey. Okay? So that made me think, oh, well, you know, everything I read on the internet may not exactly be true. Okay, late summer, dries up. No more food coming in. Go into survival mode. At this point, attrition exceeds recruitment, and you slowly start dropping the population of bees in the hive. Again, get rid of any extra mouths to feed. So same thing in Manitoba. And at this point in time, here's that fresh honey stored. This is from my area. Look at how spotty the brood is. Every one of those cells had an egg in it. And the nurses just follow along and they cannibalize them. They'll cannibalize 1,000 eggs a day, every single day. Okay? Because there's not enough pollen coming in. And this is when Varroa really becomes a problem. So we'll talk about my Varroa model in my next presentation.
Randy?
Yeah.
Sorry. So you mentioned before that the size of the colony and the stores and all this is controlled primarily by the nurse bees.
Yes.
Right? Does the queen ever make any of these decisions?
No.
So she's just a machine, right?
Yep.
And so if there's a drop down in
And she's a machine controlled by,
the nurse bees.
how do they control her?
And what?
How do they control her? By how much jelly they feed her. That's her only food. Jelly is such a perfect food for the queen bee that her feces looks like clear drops of water.
So they control her.
They control
So
her.
this food makes her slow down. So it's not like she's still laying them and they're just cannibalizing.
Right.
She'll actually slow down.
Yes.
And that's all controlled by the nurse bee.
Yes. Okay. So now, as this colony population starts to drop down, Varroa didn't get the memo. They continue to reproduce, and suddenly your proportion of mites to adult bees explodes in the fall. Not because Varroa, see, the growth rate of Varroa was pretty slow still here, but suddenly you have fewer bees with the same amount of mites on them, and or same total number, so much larger. Let's see, we're gonna, okay. Then come fall, the bees will actually start storing pollen in this bee bed for winter survival food, even underneath the brood. And this is very important in long, cold winter areas. This allows them to do a little bit of brood rearing during the winter. One of Lloyd's colonies put into cold storage for the winter came out of cold storage with more bees than it went into cold storage from winter brood rearing with no foraging whatsoever. And that's what Farrar found for Midwestern beekeeping. And I would suggest it would apply to Alaska. You want to go into winter with as much pollen reserves stored as possible, and that will allow that winter brood rearing. And any bees reared now will become these long-lived diutinous bees right here. This is data from Heather Matala showing how here's the survival curve from 100% survival to 0, emerging in July and August and October. And then after that point, once they stop rearing brood, then they have a very low mortality. They initiate brood rearing right here, and bam, then a month later, they start foraging and die. So for us, in late summer, we first control the mites, and then we will feed pollen sub if it's indicated. If they don't consume the pollen sub, we just walk away from them. Don't waste time. That colony's not going to make it.
Do you have a preference for the pollen substitute?
Yeah, you should go on my website. I've tested a number of them, and it's evolving. I'm working with some new manufacturers to try to improve them. The best we found was a homemade one. And I got the recipe on my website. So the pollen sub, they also need the syrup in order to give the moisture for them to make the jelly. Finally, you get your first frost, brood rearing is over, and you can see this happened right here in Manitoba, and minimal brood rearing from that point on. Emerging workers now becoming nurse bees, they are arrested nurse development or winter bees, but winter bees happen in July in California. If they're not feeding brood, they don't fly. They don't get pushed off the combs by the emerging brood, and they just go into long-term survival mode. They tank up on all the pollen they can, and they just store it in their fat bodies as a reserve in their bodies. Then you get the fall turnover, where any remaining bees that ever foraged, all these guys, their cohort just disappears from old age. And you often, for a strong colony, you may drop in colony strength by half come November. Now, the old axiom was take your winter losses in the fall. Don't waste your time trying to winter weak colonies. Combine them together and get a decent cluster size. You want to have a proportion between your big enough cluster size for the box you're going to put them in. I think Tim's going to be talking about that for overwintering. Very, very important. You don't want to winter them in too much space right there. Nowadays, we see very high winter losses because beekeepers are going to almonds and they try to keep every damn colony alive. So, of course, you're going to have higher winter losses. The winter cluster then makes this what looks like a ball of bees, but it's not. It's a shell of bees around a loose ball of tropical bees. Give them a puff of smoke, and you can see these bees in the center were warm, and they move away. These bees on the outside get down to 55 degrees and do not drop below that. So they form this tight, airtight shell. The carbon dioxide content goes way up inside the shell. The oxygen content goes way down. There's almost no air exchange. They completely control this environment right there. They prefer to have minimal ventilation. And beekeepers throughout the years have always thought about, oh, let's ventilate the hive, let's help them out this way. And the bees for an equal number of years going, what the heck are you doing? And they will close those holes up with propolis. Some beekeepers listen to their bees and some don't. Top insulation is very important to avoid this heat loss on the tops of the hives. And then I shifted the axis here to show minimal attrition of these long-lived bees during the winter until they start rearing brood again in the spring. They will, one of the reasons for that midwinter brood rearing may be for water, excess water, to get rid of it. If the bees can't fly, if they have a gut full of water from digesting honey and get the metabolic water from that, they can't get rid of it unless they evaporate it through their spiracles. But if the humidity is high in the hive, they cannot evaporate water from spiracles, and their rectums get chock full of water. They can't fly out, they're going to explode. So what do? Produce jelly. Rear some brood and feed all that moisture out in the form of jelly. So that may be the reason why they initiate brood rearing, and for some reason, there's been almost zero research on this. And then they will do this brood rearing during the winter, even though they have very little bee bread maybe in the hive, but it takes about 3 bees' fat bodies to raise one larva, so they can't do too much without pollen bee bread stored in the hive. Down in California, we can feed right in the middle of winter and grow huge colonies, even though they're not flying much. And then the first 3 pollens come back again, we complete the cycle, and that's it. All right.